Hello dear students, good morning everyone, and today we are going to go ahead in our lecture in the standard 9th science, and that will be the structure of atom. Today we are going to discuss further in this chapter, but before we go into the further discussion of this chapter, let us take a brief preview on what we have studied so far in this chapter. Already we have studied in this chapter is that what is the structure of atom, what are the particles that is come and made of the atom. Already in chapter 3 we have seen that the atom is normally cannot be break down further, but in the chapter 4 we have said that the atom can be also divided, and it will create a subatomic particle. Mostly the subatomic particles are known as the electron, proton and neutron. So there are so many scientists that have discovered the particles or the subatomic particles in the atom. Like we are going to discuss in today's chapter, that electron has been discovered by some scientists, as well as proton is also discovered by scientists. So we are going to discuss that why this subatomic particle has been discovered, what is actually the charge of electron, what is the actually charge of the proton, what is the actually charge, why it has some kind of specific charge, like electron has a negative charge while the proton has a positive charge. So we are going to also discuss that in today's lecture. Afterwards we are going to discuss that some of the scientists have given us some basic model regarding the structure of atom. Likewise, already we have already studied in the previous lecture that many scientists have given us the model, but afterwards and after a long discussion there is a one scientist that has given us a specific model regarding the structure of atom, and that we are considering in today's daytime. Okay, so we are going to discuss that. Okay, so let's begin today's lecture. Okay, from the first topic, that is the nucleus of atom. Okay, already we have talked about the structure of atom. Into that we have seen that there is some specific basic tiny structure in the atom which is fixed, which is already stable, and that stable part of the atom is known as the nucleus of the atom. So we are going to discuss that first. An atom consists of a cloud of electrons surrounding a small dense nucleus of protons and neutrons. So we have discovered that, or the scientists have discovered that the atom consisting a small cloudy like structure. Into that there is a two subatomic particles are present, which are the protons and neutrons. Okay, so the first is the atom consisting around a small dense, and it consists of neutrons and protons. These are the two parts that will be mainly present into the nucleus of the atom. So we are going to study about the first, protons and neutrons, because it lies beneath the nucleus. Okay, nucleus is made up of two particles, two subatomic particles, which are proton and neutron. Okay, the nucleus contains nearly all of the mass of the atom. Already we have seen in the chapter number 3 that all the atom consist the atomic mass. Already we have seen the topic of atomic mass in the chapter number 3, in which we have told that the atomic mass is considered into the basis of the nucleus, because all the main functions or all the main things which is present in the nucleus. So neutron and protons are present in the nucleus. So basis on that, the atomic mass will be considered. Okay, because it is a main point and it will be considered as the mass of the unit. Because what happened, the atom has like this structure. This is the proton and neutron. I will change the color so you can visualize it. Okay. So this is the proton and neutron, and you know that the electrons are always rotating around it. Okay, so electron is not stable. So due to its instability, we cannot consider it into the atomic mass. So for considering into the atomic mass, we need a proton and neutron, okay, which lies beneath the nucleus. So that is why the atomic mass is always considered in the basis of the nucleus, because whatever the mass of the nucleus is the mass of an atom, okay, because again I am saying that the electrons are revolving around the nucleus and it is not stable as proton and neutron. So that's why we are not considering into the atomic mass. Okay, let's go ahead what they are talking about. But it occupies only a tiny fraction of the space inside the atom. The diameter of the typical nucleus is only about 1 into 10 raised to minus 14. See, here is the important part. 1 into 10 raised to minus 14, which means it contains the 0.00014 zeros and then 1. So it is so small that it cannot be calculated also. We cannot see it from the naked eye. We'll have to, if we want to see the nucleus, we'll have to use the electron microscope, and there we can see the nucleus of the atom, because we cannot see atoms from our naked eye. So for that, it is very much important that it is smallest diameter. Okay, we can 0.000. We'll have to go to the 14 zeros and afterwards 1. Okay, or about a 1 upon 1000000 of the diameter of the entire atom, which means 1 upon 1 lakh of the diameter of the entire atom. So this is the important topic. Okay, sure. We are going to the next topic, that will be the electrons. So it is a very much important topic. Now we will have to discuss that, because electron and proton are the main parts. We will have to study the neutrons, but the electrons and protons are the main part of the atom. Basically, because of the electrons and protons, the atom is always giving us some specific features, some specific characteristics on the basis of the electrons and protons. Okay, so that's why it is very much important to us. Okay, so electron, because we know that the subatomic particles are further categorized in this chapter. So the scientists who have discovered the subatomic particle will have to do the study regarding that. Whoever the scientist has given us the concept regarding the electron, who is the scientist that has given us the topic regarding the proton, and what are the charges, on the which basis they have found the electrons are present, on the which basis or which factors that are affecting the electron and protons further studies. Okay, we are going to do that. So that's why it is very much important topic. Electrons were discovered by Sir J.J. Thomson. The first point that will be, we'll have to see that who is the scientist that has discovered the electrons. So it is Sir J.J. Thomson, okay, who has discovered the electrons in the atom. It will be come in the MCQ. Okay, so that's why it is important. Electrons are tiny, negatively charged particles around the nucleus of an atom. So, negatively charged particle around the nucleus of an atom. Already we have discussed that this is proton and neutron, and into the orbit of they are revolving electrons, okay, which has a negative charge, and that is why I am specifically giving you a sign that represent the negative sign. Okay, which basically represent the electron, because it is a negatively charged particle. Each electron carries a single fundamental unit of negative electric charge, which is minus 1.602 into 10 raised to minus 19. Okay, it is a power, basically minus 19 is a power, and minus is why we are adding, because electron has a negatively charged, that is why we are adding the minus. Okay, and it has a mass of 9.1019 into 10 raised to minus 31 kg. It means minus 10 raised to minus 31. We'll have to put the 10 raised to 31 into the division of 9.109. Like we'll have to, if you want to write this basically, that 9.109 upon 10 raised to 31 means we'll have to divide 9.109 with the 31 zeros. Okay, if we divide the 10, they are going to the crore, arab, and afterwards. Okay, so we have to divide, and whatever the value come after this, okay, it will be considered the mass of an electron. Okay, so that's the mass. So you will see that it is very much smaller. Okay, mass is very small because it is electron and they are revolving around the atoms, and that's why we cannot see it from the naked eye. So it has a small mass, but if we want to calculate, then this is the method we can calculate it. Okay, likewise, if we want to see the charge, okay, then charge is always calculated in the Coulomb, because Coulomb is the scientist that has discovered the charged particle. Okay, he has given us the concept regarding the charged particle. So that is why we are adding the Coulomb. Okay, Coulomb is the SI unit of the charge. Okay, for proton it is also a positive charge, so charge unit is always Coulomb. So that is why we are considering a proton's charge into a Coulomb also. And then the electron is one of the lightest particle with known mass. Electron cannot be split into anything small. Also, electron do not have any real size, but are instead true points in space. That is, electron has a radius of 0. Okay, that are the points that we are going to discuss. That electrons are very much smaller than we cannot consider it in a real actual world. Okay, we have just imagined that they are revolving around in this orbitical structure, because in actual life, on reality, we cannot imagine that what is the radius in which they are performing this activity. We know that we can imagine that electrons are revolving around the orbit, and orbit is made up of a radius, like orbit is made up of the circle, and circle has a radius. So on the basis of that, we are imagining that. But in actual world, we cannot determine that what is the specific radius value of these electrons, okay, in which they are revolving. So for that, we have to go deep inside it, and we'll have to imagine it, and we have imagined that. Okay, so that's why we are thinking about this. Okay, see, these are the points. Now we are going to the next slide. Now we are going to study about the neutron. Now neutron is what? Neutron was discovered by Sir James Chadwick. Okay, the scientist who has discovered the neutron. Okay, again we have to go for the neutron, and the scientist who has discovered is Sir James Chadwick. The first point. It is also come in the MCQ. That who is the scientist that has discovered the neutron? So it is Sir James Chadwick. For electron, Sir J.J. Thomson, he has discovered the electrons. Now Sir James Chadwick has discovered the neutrons, particle, subatomic particle in the atom. The neutron is slightly heavier than a proton and 1838 times as heavy as electron. So you can see, and you can just imagine it, that if I am saying that if an electron has 1 kilogram of mass, if an electron has a 1 kilogram mass, then neutron is automatically 1838 kilogram of mass because of this electron, because it is more than that. proton. Sorry, I have written the electron. I have told you the electron, but it is proton. So if a proton has a 1 kilogram of mass, then the weight, then neutron has a 1838 times more mass than proton. Neutron electrically neutral elementary particle because it has no basically charge. Okay, so that's why we are considering neutron has a no charge, or neutron has a constant charge. Okay, we are considering that it is considering no charge particle. Okay, the neutron is about a 10 raised to minus 13 centimeter in the diameter. Okay, it means 1 upon 10 raised to 13, and we have to divide 1 by 10 after 13 zeros. Okay, whatever the value come, it will be diameter of the neutron. Okay, then and weight is 1.6749 into 10 raised to minus 27 kilogram. So see here, because of its no charged property, because it not contains any kind of charge into it, so there is no value for the specification of the neutron's charge. In the electron we have seen the value of the charge, in which we have already told, I have already told you that it will be considered in a coulomb. Okay, so charged value is always considered in the coulomb, but because the neutron has a no charge unit, that is why it is considered, that is why it is not given here that neutron has what charge. Okay, so it has a two specific value into which we have to memorize the value of its mass. Okay, which is 1.6749 into 10 raised to minus 27 kilogram. Okay, so this is the value we have to memorize it, because it is scientifically proven fact that this is the value of this. Now we will have to discuss the protons. So protons are made up of extremely tiny particles. Atoms are basically made up of extremely tiny particles in which the protons, neutrons and electrons present. Protons and neutrons are in the center of the atom, making up the nucleus. Electrons surrounding the nucleus. Already these facts you know it very well. Okay. See, it is the important point that you have to see. It is a mass, it is the charge, it is the symbol, and it is the particle. So for that, electron has a symbol E minus. Okay, charge is minus, mass is this. Proton is represented with the P plus, charge is plus 1. This is the mass. You have to memorize it. Neutron, no charge, so that is why its value is 0. And mass is this. Okay, I am giving you a 30 seconds of time so you can visualize it, or you can make the notes out of this. Okay, I am just giving you a notes, short notes. Okay, I am giving you a 30 seconds of time so you can see that and you can memorize it. Okay, so I hope you all can understand it. Now we are going to the next slide. Okay, if you want to write this, you can pause it the screen. Okay, on your YouTube or in your PC, in your mobile or in your tablet, whatever on which whatever the equipment you are watching it. Okay. Now there are basically so many rules to determining the number of subatomic particles. Like I already told you on which factors, what are the specifications, what are the characteristics on the basis of we are considering the subatomic particle. So regarding that, there are so many rules to represent the subatomic particle. For that, we are discussing the some of the rules to give us the facts of the number of subatomic particles. This is a very much important topic, because if you once you understand this topic, it will be a very much useful in the 10th standard. It will be much more useful in the 11th-12th science chemistry portion. So that is why you have to understand it with focus. So the number of protons, neutrons and the electrons in an atom can be determined from a set of simple rules. See, these are the simple rules. We'll have to just see that. There are 4 rules we are going to see that. The first rule, the number of proton in the nucleus of the atom is equal to the atomic number Z. Now you have seen that some of the elements name. You have already remembered the elements name from the chapter number 3. As we have discussed in the classroom that you will have to memorize the table of the elements. Okay, in that you have seen that hydrogen is represented with H, sodium is represented with the Na, zinc is represented with. Okay, so you have already seen that. Okay, you have already remembered that. Okay, like nitrogen is N, oxygen is O, carbon is C. So these are the basic simple elements table and the symbolic representation of that. But we will have to further categorize into some specific table. Okay, we cannot just memorize with sodium, then zinc, then iron, then hydrogen, then oxygen. So it has some specific numbers, okay, in which we will have to memorize them, okay, because it contains electrons, it contains the proton. So on the basis of that, they have given us a topic of atomic number, in which we have to see that the number of protons present in the element. What I am telling is that the number of proton which present in the element is given as an atomic number. For example, if I am telling you that the hydrogen has 1 proton into that, it means it is given as the specification that the hydrogen has an atomic number 1. So whenever we are making the table on the basis of the atomic number, we'll have to specify the hydrogen into the first category, because it contains the number of proton is 1 into that. So that's why. So that is given as the specification regarding the atomic structure of the our elements. Okay, on the basis of that, they have given us a table. We are going to discuss that in the next lecture or in the further lectures, that would how to memorize that table. Okay, we are going to see that, so don't worry about that. So we are discussing that the number of proton which present in the nucleus is automatically represented the number atomic number of that element. Okay, the first thing. On basis of that, we are going to discuss another rule. Okay, second topic. The number of electrons in the neutron atom is equal to the number of protons. See, the number of proton is always equal to the atomic number. Now, the number of proton is always equal to the number of electron. Whenever I am telling you that hydrogen contains the 1 proton, it means it given us the 2 basic ideas. The first idea is it has given us that the number of proton is 1. It means it automatically given us the atomic number, which is also 1. And it automatically given us the second idea that hydrogen has contained 1 electron in its orbit. Okay, so from the number of proton you can identify the 3 things. First, number of proton. Second, the number of electron. And third, the atomic number of that element. So that's why it is very much important. 2 rules. Okay, on the basis of that we have categorized this element. Okay, because elements always contain the electrons, and this electron structure is always different for the different element. So we are going to discuss the third point now. The mass number of the atom M is equal to the sum of the number of protons and the neutron in the nucleus. Now, whenever we are considering the mass number, we have already calculated the atomic mass in the chapter number 3, and which you are what you are doing, you are taking on some mass of the nucleus. In that nucleus, it contains these two subatomic particles. That will be the proton and neutron. So, what you are actually doing, you are taking an actual sum of proton and neutron on the basis of the nucleus, and it is already given in the form of the addition. Like we have seen that oxygen has a 16 U of atomic mass in the nucleus. So it given us the basic idea that it oxygen's nucleus into the nucleus there is proton and neutron. They have already given us the addition of proton and neutron into the nucleus. So we have calculated that. Okay, already we have calculated that. This is a simple rule that the mass number is identified or it is determined by the sum of number of proton and neutron in the nucleus. The number of neutron is equal to the difference between the mass number of the atom and the atomic number. See, if we want to find the number of neutrons, what we have to do, we'll have to subtract or we'll have to find the difference between what? Mass number and atomic number. If we find the difference between, again I am saying that if we find the difference between mass number and atomic number, so if you want to find the number of neutrons, if we want to find the number of neutrons, what we have to do? We have to do subtraction. Difference means what? We have to find the subtraction. A to that we will have to subtract what? Mass number. Mass number is represented with M minus atomic number, which is represented by Z. So if we want to find the number of neutron present in the element, we'll just have to subtract M minus Z. Okay, this is the simple formula to find the number of neutrons, because in 3 rules we haven't seen that how to calculate the number of neutrons. So for calculating the number of neutrons, we'll have to make a formula, and for working on formula we are doing a formula regarding the number of mass number minus atomic number. Okay. The difference between the electrons and protons, this is important. Protons have a positive charge, electron has a negative charge. Proton is significantly heavier, while it is comparatively light in the weight. Protons are larger in size, electrons are smaller in size. Protons remains in the nucleus while they are rotating around the atoms. Protons are present in the nucleus clouds while electrons are present in the shells. I have already told you in the first lecture that they are always rotating around the shell. Cells means orbital structure that is present around the atom's nucleus. Okay. So I am giving you 30 seconds of time, so you can write that. Okay, or you can pause the screen and take a screenshot, and afterwards you can write that. Okay. Okay. So I hope you all can understand this topic. I am giving you a homework. Okay, in the next lecture we are going to discuss about the basic models that is given us by Rutherford, Thomson's. Okay, we are going to discuss that in the next lecture. So in today's homework, we have to write. I am finding the space where I can write the homework. Okay. I will make sure that I will put a one blank slide next time in this PPT. So if I cannot find the space, okay, I am writing it here because I haven't put a blank slide in this PPT. Question number 1. Write a short note on electron, proton, and neutron. question number 2. Rules for rules for atomic structure. And number 3, difference between proton and electron. Okay, so these are the 3 questions that you have to write in the homework. Okay, so that's it for today. Thank you very much for reading this lecture. I hope you all can understand it from your house. Okay, we'll have to make sure that we are not going to miss any lecture from the science, because this is important, and whatever the situation we are facing of, it will be our we can say that we'll have to manage these things, okay, in our life. And I hope you all stay at your house, okay, wear mask, sanitize your hand, okay, very well, and I hope stay safe, stay healthy, all of you. And thank you very much for this lecture. If you had any kind of doubt, you can ask me on the comment section. You can ask me on personally on my WhatsApp. Okay, till then, bye bye everyone. Take care of yourself.